Howdy ho, Math Wizards, Mr. Orgak here, and today we're going to start Unit 5, and Unit 5 is a whole lesson on systems, solving systems of equations. First up here in Lesson 1, we're going to solve a system of equations graphically, so that's what you're going to need to do. You graph two lines, which you already know how to do, and where they hit, that's going to be your solution. So that's our goal, that's our objective, to graph two lines and two systems equations, find the solution. Alright, in exercise 1, we want to determine if 2, 5 here is a solution for the following sets of systems. This set, and then eventually we'll get to B here and do that set. So we're going to start off, as you know, the 2 here is your x variable, and the 5 is your y. So we are going to take those and plug them in right here. So you start off with y is 5 equals 4 times 2 for the x, and then minus 3. So 5 equals 8 minus 3. And 5 equals 5. Beautiful. That one checks. However, you're going to learn that it has to work in both equations. Otherwise, you're just picking out a point that's somewhere on that line. So when I go to the other one, I got 2 times x is 2 plus 5 has to equal 9. So 4 plus 5 has to equal 9. And 4 plus 5 does equal 9. So that works as well. Therefore, it is a solution. No problem. Yes, solution. Okay? Now, I want you to pause the video, and I want you to go to B, and I want you to give that one a try. All right, let's see what you did in B. You should have had on this one 5 minus 2 equals 3. 3 equals 3, so bingo, that works. Now, if you were lazy and you stopped right there, let's see what happens here. Put 5 in for the y on this one, times half of x, which is 2, plus 6. So 5 equals, well, what's half of 2? That's 1. 1 plus 6. Does 5 equal 7? No, does not equal it. So no solution here. Not a solution. And that's how you check these babies. You just plug them in and make sure to work. And after you graph each one we're going to do in this unit, you really should be doing this check to make sure you got it right. All right, let's move on. All right, in exercise 2, we're actually going to get to the meat of the unit here on this lesson. We're going to actually solve and graph. So you know from the previous units that the m in this case is, remember, it's y equals mx plus b. So the m in this first one is that 2 out in front of the x. Do not write the x. And your b is that plus 5, so it's a positive 5. If you want to rise over run, put it 2 over 1. Obviously, that's how you make a fraction. So change in y over change in x, if that's what you're looking for here. So I'm going to start up 5 units and put a point up here. And then I'm going to go up 2 over 1. Oops, we're going to run out of space here, aren't we? So remember, you can do the opposite. Instead of going up 2 over 1, you can go down 2 to the left 1. Down 2 to the left 1. Down 2 to the left 1, and so on, okay? And that will get us our points. All right, with that being said, I'm going to actually connect them now. And I will do a line that will go through each of those pretty close. I might be off a little bit. And you've got it right there. So that's our equation, y equals 2x plus 5, which you should label always so you have everything down there. All right, let's change colors. We're going to let's go to blue here. And under this one, now I know it's a weird order here that you're looking at, but what number's in front of that x? Well, it's just a minus sign, so it's really a minus unwritten 1, which you could put over 1. And the plus part is the 2. They reversed it for you. So this time you start up 2, so I'll put a blue one right there. And I'm going to go down 1, over 1, down 1, over 1, etc. Going like this. So now I'll connect those as well. The line going through, and that's my other equation. So that would be y equals 2 minus x, everything labeled. All right, so what's the big deal out of this? The whole thing comes down to where do these things intersect. And your solution here, which I guess I'll do in green here, is this right here. That's our solution right there. So what's that point? It's negative 1 to the left, up 3. So negative 1, comma 3 is the intersection. That's the point that will work in both. Well, part C now wants you to check it. So obviously, just like we did in number 1, you throw in the 3 for the y. 2 times a negative 1 plus 5 you'll get 3 equals negative 2 plus 5, and so 3 equals 3. It works, but once again, don't get caught into just checking one of them. Check them both. So the second one, you plug in 3 equals 2 minus a negative 1. Don't lose those signs. So that equals 3, and 2 minus a minus, remember, is plus a plus. So that's plus 1, and 3 equals 3. So the equation works for both, so therefore my solution is correct. All right, that's what we do, and that's the main gist of this entire lesson, is to graph two lines, see where they intersect. That is your solution. Time to move on. All right, in exercise 3, we got some vocabulary words, and you got a word bank here of true, intersection, solutions, both. So let's answer these questions. Number 1 says, to solve the system of equations graphically, you need to find what of the two graphs? Well, for number 1 here, that's intersection. Okay, so that goes with number 1. Where they cross, that's the solution. Number 2 says this works because any intersection point must lie on what? Well, on what graphs? The solution graphs? No. True graphs? No. Both. It's got to be on both graphs. That's why it's the intersection. So number 2 is this one. Number 3, because the intersection point lies on both graphs, they must make both equations true. Okay, that's where we were testing it out in that one part, both part question 1 and part of 2. And finally, last one here, because the intersection points make both equations true, they are called solutions. So that's your answer to the vocabulary word 4. All right, let's move on and do a big thing of putting this all together in exercise 4. All right, in question number 4, it tells you that Janelle and Swetha are taking 50-question true-false test. Janelle started off after Swetha had already done 12 questions. Janelle answers 2 questions per minute, while Swetha answers 5 every 4 minutes. Janelle eventually catches up with Swetha, which is good to know, and our job is to write a system of equations, graph them, and determine when she actually catches up. So if I'm going to start off with this thing, I know the bottom of your graph says let m equal the number of minutes, and that's fine. I'm going to call it x because I always like x. So let x equal the number of minutes, just so I can stick in the system of y equals mx plus b. So number of minutes. And when I go to graph this here, we got Janelle and we got Swetha. Well, Swetha actually starts off with a little bit of an advantage, if you remember here. There's a 50-point question test, which is good to know. But Swetha has already done 12 questions, so that's critical. So she starts off with an extra 12 already in her pocket being completed. So then they tell you Janelle answers 2 questions per minute. Well, you hear that, questions per minute. That's rate. That's your slope. Okay, so that's the m and the mx plus b, if you're talking about the regular m. So she does 2 per every minute times x. Plus, if you want, she starts off with no questions done. So you don't need that part, but if you want the plus 0, put it in there. And Swetha, on the other hand, says she answers 5 questions every 4 minutes. So that's 5 every 4 minutes. And that's how you write the slope for Swetha's. So you've got 2 systems of equations here. Perfect and ready to roll. You can punch these in your calculator now and get your table and write down your table if you want, and then go ahead and graph them on the next one. I'm going to go and do it the old-fashioned way on the next one, so hang in there or we flip the page. All right, on the page here, I'm going to do Swetha's here first. If you remember, Swetha was 5/4 x plus 12. Okay, and when I do that, it actually means my m is equal to 5/4 and my b is equal to 12. So if I'm going to start these, so I'm going to start up 12 here. And if you notice here also, a key is that each one across the x down here, each box is worth 1. There's 5 boxes for 5, but 5 boxes here for 10 means each one of those is worth what? You are correct. It should be 2. So if I got to go up 5 and over 4, that means I actually got to go up 2.5 boxes and then come on over 4 spots. There's my next point. And when I do it again, I go up 5 over there. So up 2.5 boxes over 4, up 2.5 boxes over 4, up 2.5 boxes over 4. And as you can see, I cheated and already put those in because it's a tougher one. And if I go and graph this line, here goes my line straight through. Perfect. We're all set with Swetha. Now I'm going to change to Janelle. We're going to take a look at hers. Hers, on the other hand, said we were at, when she was doing it, Janelle was actually equal to 2 over 1 x and then plus 0. So she actually starts right down here, the origin. And you got to go up 2. Well, every box is up 2 is really up 1. So up 2 over 1 means you got to go up 1 box over 1, up 1 over 1, up 1 over 1, and so on. Oops, we will undo that part. So, as I'm going through these, like I said, up 2 over 1, up 2 over 1, etc. So now we're going to graph this thing. So as I'm going through it, we're going to go right through those lines there. And bingo, there's my line. To answer the final question there for part B, it said, well, when does Janelle actually catch up? Well, if you take a look here, there's our solution. Where did they cross? Well, it looks like I'm over here, coming on up. So that's 16, comma, and I'm up at what height here if I go across? Well, that's worth 232. What does that really mean? Bottom line is, it takes this, and she basically caught up in 16 minutes, and they each answered 32 questions. So remember, that's the minutes. So in 16 minutes, Janelle finally caught up to her, and they both had, at that point, answered 32 questions. Sorry, my 2 looks bad here. All right, there we go. All right, make sure you write a nice WSQ tonight, and get ready for class tomorrow. But the bottom line is you graph the 2 lines, and we're ready to roll and see where they intersect, and you're solving systems of equations.